Okay, it's more than tools. We all know this. People and process need ample attention for success. And so the way I've sort of divided up the success factors here is to group it into three stages. There's design of data pipelines, operation, and then adaptation. The first principle or success factor for effective design of data pipelines is to align with business priorities. It's critical and it's a cliche, but always worth restating because um, with the best of intentions, enterprises forget this. You need to start with what the business requirements are, go to the business owners, get executive endorsement, and from that, build out your use cases. Maybe you have a desire to improve cross selling for a given business unit on your e commerce website. Maybe you have a desire to improve operational efficiency and reduce downtime with your fleet of delivery trucks. There are a lot of very specific business priorities that need to guide everything that happens thereafter. Another important principle of design is scoping not just current but future requirements. Um, During my time at Attunity, we found that a lot of organizations were interested in standardizing on tools that could handle a whole set of sources and a whole set of targets, some of which they didn't even have yet. So they wanted to future proof, if you'll permit the term, what they had, because they understood that they have dynamic protein environments that will change, and they wanted to make the pipeline tools a constant factor so that they could spin up new pipelines and adapt them as they saw fit. Embracing graphical tools is critical. There are many data engineers, I'm sure there are plenty of practitioners and leaders on this call that will prefer the command line interface to handle custom work, to handle specialized transformation tasks, and so forth. But most folks now recognize that they need to reduce the time spent on repetitive, error-prone tactical stuff, and graphical tools can help quite a bit. Graphical tools also, a graphical user interface and a no-code, low-code approach can help democratize data access so that business-oriented analysts and so forth can actually roll up their sleeves and get into data preparation themselves. When we look at operation, there are a couple of key principles here that are very closely related. First is automation, putting automated processes in place as you schedule and configure and schedule and monitor workflows, as you automate monitoring and alerting. All these things can help improve efficiency and the productivity of your data engineering teams. This aligns closely with standardization of elements. It's critical to reuse, to standardize certain elements so that you can view your pipeline artifacts as Legos that can be used interchangeably in a modular fashion. This greatly improves productivity while still enabling data managers and data consumers to reassemble components and meet their specialized requirements of the moment. Adaptation. At the outset and throughout the process, or enterprises and data engineering teams need to monitor the technical and the business key performance indicators. They need to make sure that the latency, the throughput, the concurrency, the uptime of their pipelines meets their SLAs. They also need to make sure that they're delivering the right data to the business to support machine learning models, to support business intelligence reports, and so forth. And so those business and technical KPIs can really help guide data engineering teams as they need to adapt their data pipelines. Optimizing quality and performance is a critical element here, and a lot of this gets to looking at the quality of data, validating the accuracy of that data, and making sure that the pipelines are delivering the data on time and responding to red flags that are rising from the KPIs. We talked about reusing modules, and that's going to support making modular changes to your pipelines. So successful data pipelines are going to depend on effective design, operation, and adaptation.